In this video, we're going to discuss the applications of conics. So we've already talked about basic conic sections, which were circles, ellipses, parabolas, and hyperbolas. What we're going to do now is take those basic concepts and we're going to apply them to the questions on this page. So I'm going to start with question number 1. Question number 1 states that we need to find the equation of the line that is tangent to the circle given by that equation at point 3, 5. Okay, well, unfortunately, it doesn't really specify what form it wants the equation in. So there's 3 different forms that we could technically write this in. We could write it in point slope form, we can write it in standard form, or we could write it in slope intercept. For the purposes of this question, I'm just going to write it in point slope form, just to make it easier on ourselves and we won't have to think too much about it. If I ask you to write it in slope intercept form, which is y equals mx plus b, or if I ask you to write it in standard form, which is ax, let's try that again, ax plus by equals c, you should be able to write it given this form. So let's go ahead and continue. It does tell us that the circle is at that equation. And if you look at this equation here, we can identify 2 things. We can identify the center, and we can also identify the radius. Well, if you look at the x squared and y squared, that means that your center is going to be at the origin. And for the radius, remember, this part is your radius has already been squared. So this, we actually need to take the square root of to find the actual radius. So the radius is going to be a decimal, and that decimal is about 5.83095, and it would continue. And I'll round this up to 0.95. I'll just write it that way, so that way you don't think it's a 9 at the end. Either way, we're going to take this information and we're going to try to find that equation. Okay, so this does require you to think back to geometry. So let's kind of draw this out to see what we have. We have our coordinate plane, and centered at the origin, we have this circle. This circle that I just drew in green has a radius of 5.83095, blah, blah, blah behind it. So it also, if we look back at the steps or the directions, says that it is tangent to a point 3, 5. Okay, I don't want to be too exact on this because I don't feel like counting out things, but this point right here, we're going to say is 3, 5. And this would be the tangent line that goes through it. It's touching it, so we want to make sure that it only touches one time though. Okay, perfect. So this is our line that it has to touch. Okay, well, we need to think about a few things first. Okay, the first thing I need to think of is if I'm going from the center of my circle out to this point that's tangent, if you think back again to geometry, that distance will make it perpendicular. That line will intersect this radius at a 90-degree angle. So there's a few things I'm going to need to find. The first thing I need to find is the slope for the line that goes from the radius to your point 3, 5. So we're going to find that slope first, and we're going to use the origin, and we'll use the point 3, 5. So I'm going to take my slope, and I'm going to substitute this. y2 minus y1 over x2 minus x1. This is your x1, y1. This is your x2, y2. This is basic slope you learned back in Algebra 1. I'm going to go ahead and simplify, so this will give me 5 over 3. This is the slope that goes from the center of this circle out to the point that is tangent on your line. Okay, well, we need to think about this. Well, if we already have this slope and we know that it is perpendicular to this line, we need to write the equation of that line. But when we write it out, we want to make sure that we write it as a perpendicular line. It needs to be perpendicular to it. So I'm going to write the equation of, I'm going to put perpendicular. If I could spell perpendicular correctly. Line. What I'm trying to say with that is the slope that you already have, we need to make it perpendicular. So that way it'll actually make the equation for this red line. So what I'm going to do is I'm going to rewrite this as my perpendicular. That upside down T that you see at the bottom is representative of perpendicular, just like when you were back in geometry. And we are going to do the opposite or negative reciprocal, however you learned it. So what that means is we're going to take that fraction, we're going to flip it, and we're going to change the sign. So this will now be 3 over 5, and we're going to make it a negative. So negative 3 over 5. In order for it to be a perpendicular line, we're going to write our slope perpendicular, and we're going to need it to go through the point that is actually on that tangent line, which is 3, 5. All I need to do now is plug it into my point slope form. So y minus, here's your x1, here's your y1. Y minus y1 equals m x minus x1. Even now, I still plug in my point using parentheses just in case any of your signs change. Since none of them do, I'm just going to rewrite this as y minus 5 equals negative 3 over 5, x minus 3. This would be the equation that I look for on a test or quiz. If I ask you to write it in slope-intercept form or standard, you should know how to get that equation from here. All right, let's look at question number 2. Question number 2 says, Bernadine is taking an archery class and decides to practice her skills at home. She attaches the target shown to the right to a bale of hay. The circles on the target are concentric and equally spaced apart. So on this diagram that we obviously have 3 circles. We have the inner circle, the middle circle, and the outer circle. We can safely assume from this picture that 24 would be technically the diameter of circle C, and it would also, down here, the 24 would be the diameter again of circle C, since circle C is the bigger one. Okay, now that that's known, let's look at the part A. If the common center of the circles is located at the origin, write the equation that models the largest circle. Okay, so let's take a second and think about this. When it says the common center of your circles, the common center that they all have is circle A, because literally circle A is right in the middle. So what this is saying is that we need to assume that the center of that circle is going to be located at your origin, which is going to be the coordinate 0, 0. We need to write the equation of the largest circle, which is circle C, based on that information. Okay, well, we already talked about this a bit. I told you that this largest circle has a diameter, which goes from each side of your circle, right across, of 24 inches. If you think back to Algebra 1 or even geometry, your diameter for this is equal to 24 inches. That means if we were to find the radius, we would just need to take half of that. So that means that your radius is going to equal 12 inches. Since we know that your circle is centered at the origin and it has a radius of 12, we can just write our equation. We saw in the last question what it looks like when you have an origin as your center, so I'm just going to rewrite it anyway. We're going to have x minus 0 squared plus y minus 0 squared, and we're going to set that equal to 12 squared. This is your h, this is your k, and we're just using the standard form equation of circles that you saw on your conic section notes. All I need to do here is simplify the parentheses. So this will turn into x squared plus y squared is going to equal 144. This would be your answer. The second part of this question is saying if the smallest circle is modeled by the equation that's given, determine the area of the region marked B. Okay, so let's see. Technically, we have circle B is here. What it's pretty much saying is if we want to just find the area for B, we just need to find this yellow space. That's all. So let's think about it. What are we going to do? Well, I know for sure once I find the area of this circle, I could subtract it from the whole circle of B. Once I do that, I'd be able to find just that yellow shaded area. But I need to know a few things first. One thing that I need to know is that from this equation, which is technically the equation of your smallest circle, here, your center is the origin, and your radius would equal the square root of 6.25. Okay, well, let me think. As a decimal, let me use my calculator. 6.25, when you take the square root, 2.5. Okay, so using that, let me draw out what we have. I could use the circles that are already here, but especially on your paper, they're probably really dark. So let me go ahead and redraw. I'm going to draw the smallest circle. I'm going to draw the larger circle. And then I'm going to draw the huge circle outside. Okay, in this circle, what I just found is that the smallest circle has a radius of 2.5. So this small circle inside, zoom in a lot, is going to have a radius from here to here, we'll say that's the center, of 2.5. Okay, well, if we know that that is going to be 2.5, that means the diameter for this whole circle will be 5 inches. It'll just be 5 whole inches. So let me zoom out for just a second, and we're going to calculate something. The first thing I'm going to calculate, since I know that the radius is 2.5, is we're going to calculate the diameter of C minus the diameter of A. The reason why, because I already know the diameter of C. We did that on the picture. This whole diameter from here to here is 24 inches. So if I can just find the difference between the whole circle and the smallest circle, I'll be able to find technically the radius for this one and the radius for this one. So we're going to take 24 and subtract it from 5. That's going to give me 19 inches. That's not a final answer, but that's going to help me. The next thing I'm going to do, well, since I know that this is going to be 1, 2, technically 3, 4 parts of my big circle, I could take that 19 and divide it by those 4 parts. That will give me 4.75 each. So that means this distance here is 4.75. This distance here is 4.75. And so the same thing down here. We could make this distance here 4.75 and then this distance here 4.75. We could, but I just want to have it for at least half of the circle. Okay, now with that in mind, I can actually find the radius of my larger circle here, and I already know the radius of this circle. So I could actually find that area we were just talking about. So down here for step 3, I'm going to go ahead and find the area of circle B minus the area, if I could spell area correct, of circle A. So let's go ahead and subtract. I'm going to take the area of B, which is pi times, okay, well, your radius here is going to go from the center out. So I need to add 4.75 and that little 2.5. 4.75 plus 2.5 should give you 7.25. And now for the area of A, we're going to take pi and we're going to subtract or multiply it by 2.5 squared, which is the radius of the very, very small circle in the middle. All we're going to do now is compute it, guys. Go ahead and pause the video and see if you can compute this yourself. So this is what you should have gotten for each of your areas, for area B and area A. All we're going to do now is subtract. I'm going to write my answer in 2 ways. I'm going to write it in terms of pi, and I'm going to write it as a decimal as well. So if I was to write it in terms of pi, you would have 46.3125 pi. And if I asked you to approximate it in decimal form, you should get the decimal 145.495009. And I know I put in a lot of extra decimal places, but of course on tests and quizzes, I'll ask you to round it to a certain decimal place. But that should be it. Oh, and also, forgot about that. Don't forget your units, which should be square inches. Let me actually erase this. Inches squared. There we go. Please don't forget those units. All right, let's look at the next question. For question 3, this one says alpha particles are deflected along hyperbolic paths when they are directed towards the nuclei of gold atoms. If an alpha particle gets as close as 10 units to the nucleus along a hyperbolic path with asymptote y equals 2 over 5x, write the equation of its path. And it says, assume the hyperbola opens left and right. Okay, well, that left and right piece is extremely important. What that means is your x squared term needs to be first. So I'm going to make that little note down here. The first thing we need to see is an x squared first. If you think back to the notes that we did for hyperbolas, horizontal will usually mean that your graph is opening to the left and right, which means your x squared variable has to be first. So let's see what else we can do. Okay, so one thing that it did say is if an alpha particle gets as close as 10 units to the hyperbolic path, it'll have an asymptote of y equals 2 over 5x. Okay, so let's see what that means. If I was to graph this out, this will be the center of my hyperbola. This distance to here, which is your hyperbola, which will be opening to the left and right, this distance will be 10 units. Okay, let me remember that box that we did whenever we were looking at questions like this. Let me redraw that box because that's going to actually help me with identifying the other things that I need here. So I'm going to go ahead and make my little box. It's opening horizontally, which is why I'm making it longer. And that also helps me with my slope because if you remember, whenever you have an asymptote, I don't know how this is going to go, guys. I'm trying to draw it on my iPad. I don't have a ruler. But if you were trying to draw it going through your asymptotes, it should look something like this. Man, that was a little crooked. But you understand what I'm saying? It's supposed to be going through your asymptotes. Let me kind of dash that. And I'll dash it here. It's supposed to go through the center and through both corners of your asymptote. So all we need to do is figure out, well, if that asymptote equation is negative 2 over 5, that technically means from this center, it went down 2 units and then to the right 5. Down 2 and to the right 5. And it should have gone through this little corner every single time. Your asymptote should go through both corners here and both corners here. Okay, well, let's think about this. If I was to do rise over run, technically the rise is unknown. I don't know what this is. I'm going to label this as X. But I do know that the run is going to be going over 5 because I can literally keep doing that, going down X units and then over 10, and it would get me to that corner. Okay, so let's think. If I already know based on my asymptote equation that 2 over 5 is going to be your slope, that means it should equal the similar ratio of x over 10. All you're going to do here is solve, guys. So let's go ahead and solve this. I'm going to draw this work over here. We're going to make this 20, which equals 5x, and then I'll just divide both sides by 5. So x is going to equal 4. I'm not completely done, but I did help with finding out what my x value is. That's going to help me. Okay, well, now that I know that x value, I need to figure out what the equation of my line is going to be. This is going to help you with identifying your b value and your a value, which goes side to side. So I want you guys to try to write your equation. If you know that this up here is going to be your b value, and this down here will be your a, what would your equation look like? Well, since we know that x squared has to be first, we're going to put the a first, which is going to be 10 squared. Hyperbolas must be subtracted. We're going to have y squared, and we're going to divide that by 4 squared. All of this should be equal to 1. Especially since the center of this should be at the origin. It doesn't say anything about the center changing, so it's probably going to be at the origin. So we're just going to keep it centered at the origin. And then from here, we're just going to simplify. We're going to make that x squared over 100 minus y squared over 16, and all of that will equal 1. This would be your answer. If we were to have a different center point instead of the origin, I would definitely write it out. So I would definitely say it's centered at h comma k. I would give you some notification as to what your center is located at. So don't think, oh my God, do I just have to assume it's going to be at the origin? No, I will definitely explicitly state it. All right, let's look at the next question, which is number 4. The Statuary Hall in the United States Capitol is elliptical. It measures 46 feet wide and 96 feet long. If a person is standing at one focus, her whisper can be heard by another person standing at the other focus. How far apart are these two people? I want you guys to try to pause the video. See if you can figure this one out without me. The great thing about this question, guys, is it's really simple. Here's why. So we have our elliptical hall, which will look something like that. And we know from ellipticals that our major and minor axis are here and here. We do know that especially since it's going to be 46 feet wide, this distance here is going to have to be 23 units. or 23 feet. That also means that since this distance here is 96 feet, that's how long it is, half of 96 is going to be 48. So this distance here is going to be 48 feet. We are trying to find the focal points, the foci, which are here and here. Let's take a trip down memory lane. In your notes, I know, guys, that this is slanted. Hopefully it's not ruining your day. But this should be touching the center and going up to your orange point, your focus point. What is the distance here? How could we calculate that? We did this in our notes. If you look back at your notes, for ellipses. Remember down here at the bottom, I told you that C was the distance from the center to your foci or focus point. You're going to use this formula. It's not difficult, guys. That's why I had you guys try this one on your own. That's all I want you to do. So for this question, we're going to do C squared equals A squared minus B squared. I want you guys now, pause the video and find that distance for C. This distance here is going to be C. So remember, based on what we know from ellipses, your A axis here is that distance along your major axis, and then the B length here is the length along your minor axis. So we just took both of those values and we plugged them in and we simplified. We got 48 squared is 2304, 23 squared is 529. All I needed to do then was just to take the square root, and I got plus or minus 42.13. Okay, well, definitely for this question, you don't need the negative because you cannot have a distance that's negative. That doesn't make sense. But I want to ask you, am I done? Is there anything else I need to find? Well, keep in mind, guys, remember how I said you're only finding this distance here for C? The person is at the other focal point and they can hear her conversation, whoever this person is. So we need to not just find your C value, we need to double that C value because both of these lengths should be the exact same. I know my little image is a little skewed because it's not technically drawn to scale, but it gives you the idea of what you should find. So let me scroll over here. This was step 1. Step 2, I'm going to write out in order to find the distance. So the distance is going to equal 2 times C. So we're just going to take 2 times 42.13074, and then we'll find our answer. So if I double that value, that's going to give me about 84.26 feet. That will be my distance from one side of the room to the other. So pretty much from that one focal point to the other. All right, we're going to look at the next question, number 5. And again, I think this one you guys can try to do. Try to do this question on your own first. Okay, so let's look at question 5 together. A concrete bridge is designed with an arc or arch, however you want to say it, in the shape of a parabola. The road over the bridge is 120 feet long and the maximum height of the arc is 50 feet. Write the equation of the parabolic arc. So in the image, you have this arc right here that's creating that curve, and you know that it's having a maximum height of 50 feet. So that maximum word, if you think back to Algebra 1, is telling you where your vertex is. So there's a few different ways you can write the vertex for this question, guys, so be careful. I'm going to write out my vertex as 0, 50. I'm going to use, especially since it's going straight up 50 units, I can use 0, 50. It would be, here's the origin. That means at this point right here, I'm going to use, down here, that's my point, which is 60, 0. If, be careful here, guys, if you used this point here as 60, 50, you can do that. But that means that your origin would be over here to the left, which is 0, 0. And you would have the point over here, which would now be 120, 0. That can be done. It really just depends on you guys where you define your center. For me, I'm defining my center, which is the origin. I'm defining it right in the middle, right below both sides of that parabola. Because remember, parabolas create equal parts on each side. It's very symmetric. So if you were to cut it in half, it would have 2 equal pieces. Okay, with that also being said, I'm also going to make a note that this graph opens down. Okay, so let's go ahead and try to finish solving this. So let's think about it. We talked a while back on how to find the equation of a parabola. We did that on this page. So we talked about this equation here when it opens up and down or left and right. This equation is kind of ugly. If you think back to Algebra 1, we talked about these three equations. We talked about standard form, vertex, and intercept. So especially since I'm already given, if you look back on that last page I was just on, or the page you're currently on, we're given a vertex. Let's use this equation here. Reason why I don't want to use this one is because then I have to deal with that 4p, and I already know in this equation A is pretty much the same thing as your 4p. It's just already been simplified. If we were given two x-intercepts, I would probably use this formula instead. And if I was given maybe an axis of symmetry, or I could probably try to find a vertex from here, it would just be a little more effort, I could use a standard form. So let's just go ahead and use our equation here, and we're going to use that vertex formula. So let me recopy it here. Y equals a x minus h squared plus k. Okay, well now we got to pick some points. Well, luckily for us, we already labeled our vertex. This is h and k. And remember that point that I labeled all the way over here? Yeah, that's going to be x and y. That's going to be my coordinates, just some random coordinate on your graph. Preferably one that actually has a nice coordinate. If you wanted to use this point over here, what would the coordinate be if it was over here? This coordinate would be negative 60, 0. It's still going to get you the exact same answer. You're just going to have to plug in different numbers. So over here to the side, let me plug in what I have. My y value is going to be 0 equals a x minus h squared plus k. Double check that your numbers match with mine. H and k, x and y. Perfect. This looks good. I'm going to go ahead and simplify. 0 is going to equal a 60 squared plus 50. We'll subtract 50 on each side. We're solving for a. So negative 50 will equal 3600 a. And then once we do that, we're just going to divide both sides by 3600. All right, so let me look at my calculator. If I was to divide this, zeros will cancel. 5 over 360, when you rewrite this as a fraction, is going to be negative 1 over 72. That's your a value. Okay, with all that talk about that parabola, let me read the question again. It says write an equation for the parabolic arch. So for this question here, I'm just going to rewrite it as y equals a, negative 1 over 72, x minus, what was the h again? Well, the h we already said over here was 0, so x minus 0 squared plus k, which is 50. All I would need to do from here is just simplify it. So negative 1 over 72, x squared minus 50, plus 50, not minus. This should be your equation. Keep in mind, guys, there are several ways to do this question. So remember how we talked in the beginning about, well, I am centering mine at the origin because it didn't specify where it's centered. I centered it here. If you instead use this point as 60, 50, that means that the center would be over here. That means that your equation would pretty much look the same, but it would be written a little differently. So if you centered it not at the origin and you said that your vertex was at 60, 50, you would write the equation as y equals negative 1 over 72, x minus 60 squared plus 50, because this will be your vertex, 60, 50. It's something that I'll definitely keep in mind whenever I'm giving you your tests and quizzes. I'll try to specify where it's centered at. If not, it's up to you guys to pick how you want to write it, and then I'll grade it. So technically, both of these are correct answers. Both of these, they are correct. All right, we're going to look at one last question, which is going to be question number 6. So right now, we're going to look at question 6. And I want you guys, again, try and do this one on your own first. All right, let's see what we get. So for question 6, a parabolic arch is 50 feet above water at its center and 200 feet wide at its base. Will a boat that is 42 feet clear the arch at a point 30 feet above the center of the arch? Show why or why not. Okay, so this one actually is giving you a better idea of where the center is. So let me graph this out. So let me zoom in. And in this space, we're going to create a little graph just to kind of represent what we're looking at. Okay, so on this graph, we have our arch, and it's another arch that's over water. So let me go ahead and make this going up like this. And we're going to have, it's 50 feet above the water. So since it's 50 feet above the water, this point is at 0, 50. It says it's 50 feet above the water at its center. Next, it says it's 200 feet wide. Okay, so that means that this distance all along here is 200 feet. That means that this point over here, since I'm centering it at 0, 50, is going to be 100, 0. And this point over here is going to be negative 100, 0. Since it specifically said 50 feet above the water at its center, I'm using the center and going straight up. That will be my 50. The 200 just needs to add up to 200 when you add both sides. After that, it literally says that you have a boat that is 42 feet and it needs to clear the arch, and it's at a point 30 feet from the center. Okay, let's draw this out in purple. It's going to be 30 feet from the center, and it needs to clear a height of about 42 feet. So it needs to clear this point right here. I need to see if it'll actually do that. So we need to think, how am I going to do that? Okay, so if this point here is 30, 42, I might need that later. Let's start solving some things. First thing I want to do is let's actually get the equation of this arch or arc, however you want to say it. Let's find the equation of this arch, and then we'll figure out what we need to do next. I'm going to use, especially since I'm already given my vertex, which I'm going to label here as your H and K. Let's go ahead and use that point, and we can also use the coordinate X and Y, which I'm going to label down here at the bottom, the 2 points, this one X1 and X and Y, and let's figure out if we can write the equation of our parabola. So Y is going to equal A, X minus H squared plus K. Okay, let me take everything and plug it in. We'll have 0 equals A, 100 squared plus 50. I'm going to subtract 50 on each side. So negative 50 will equal, this is technically 100 squared is 10,000 A. And then I'll just divide both sides by 10,000. So A is going to equal, I'm going to write this as a decimal, negative 0.005. It is okay, especially since it doesn't say it in the directions, how to write your fraction or not. We can just leave it like this. So our equation is going to be Y equals your A value, which is negative 0.005. Since the X minus H is just really X minus 0, I'm just going to write this as X squared and then plus K, which is 50. Okay, well, that doesn't answer the question. It didn't ask for the equation. It asked, does it clear a height of 42 feet and a width of 30 feet? So let's see if we do that. So if we actually take the 30 feet, which is X, I want to see if it'll actually clear that 42 feet, because that's not the problem. It's not the 30 feet, it's the 42 feet. I want to see if I can actually get the boat through that arch. So what we're going to do is I'm going to take Y equals negative 0.005, and we're going to take, instead of X, we're going to substitute in 30. This is what we're solving. I want to see if I solve all the way down here for Y, if it'll be a value greater than or equal to 42. If it is greater than or equal to, then that means the boat will be able to successfully pass through. So Y is going to equal negative 0.005. 30 squared is 900 plus 50. I'm going to go ahead and simplify. Y is going to equal negative 0.005. Well, let me actually multiply it. Times 900, that's going to give me negative 4.5. And then we'll just add. So what does this value mean? That means that at 30 feet across, so when you're 30 feet from the center, the highest your boat can be that'll reach through your arch is going to be 45.5 feet. So what does that mean about the boat we have that's 42 feet tall? Is that going to pass through? It will. So over here in green, I'm going to write this out. Because of this, we know this is greater than 42 feet. Thus, the boat will fit under the arch or arc. This will be your answer. These questions have a lot to do with things you've seen back in Algebra 1 and Geometry, and I guess Algebra 2, but it really just relates to what you've seen with conic sections, especially the questions we did earlier. So make sure you take time to practice these questions.